Good evening, everyone. This is May-June 2020, paper 1 for Cambridge O levels. I will discuss the question which you have sent as a doubt. The first one, question 13. An unstretched elastic cord is there. Original length is 15 centimeters. So that's our original length, which is equals to 15 centimeter. And it is stretched by 4 centimeter when 6 Newton is attached. So when we add a load of 6 Newton, it increases by 4 centimeter. The cord does not exceed the limit of proportionality. What is the total length of a cord when the weight of 3 Newton? So we know force and extension are directly proportional. So if there was a 6 Newton force, it was causing 4 centimeter extension. If 3 Newton, it will cause X. When you solve, the extension will be 2 centimeter. So original length of the cord is 15, unstretched length is 15, and the extension is 2. So what will be the total length? It will be 17 centimeter because 2 centimeters extension. So original length plus extension will give us the total length. Next question 21. 200-volt battery of an electrical car is charged by 33 ampere current for 4 hours. Time should always be in second. The efficiency of a charging process is 90%. So how much usable energy is transferred to battery? What is the useful energy transfer? So efficiency is equal to useful energy output divided by total energy input multiplied by 100. The process is 90% efficient, output energy we don't know, and input, because electrical energy is power multiplied by time, but in electricity power is VI, so it will be VIT, and time should be in seconds, so you'll get answer in joules. So voltage is 200, the current is 33, and the time is 4 hours, so you have to multiply by 60 to convert into minutes, and then you have to multiply by 60 to convert into seconds. So this will be 200 times 33 times 4 times 60 times 60, and that is multiplied by 100. So we need the output, so it will be 90 divided by multiplied by this whole factor, 200, 33, 4, 60 and 60, or 3600, and divided by 100. So we'll get the output power, which is approximately equal to 86 mega joule. Mega means like 10 power 6 will be there. Next is question 25. The thermal energy produced by an electrical heater in 3 minutes is used to melt the wax. The solid wax is initially its melting point. The specific latent heat of the wax is 220. Energy supplied is 7700. How much wax? So latent heat is energy divided by mass. So if we need mass is equals to energy divided by latent heat. So energy is 7700 and the latent heat is 220. When you solve, you'll get 35 gram as the final answer. So this was May-June 2020, paper 1-2 for Cambridge O levels. Then the next paper is October 2020, paper 1-2. Question 30 and 32. Are the doubts? So in this question, a car battery delivers 150 kilocoulomb. So it means it will be 150 to the 10 power 3. That is the coulomb or the charge. And when current is 4 ampere of the current is flowing through it. So first what we have to do, we have the formula current is equals to charge divided by time. So if we need the time is equals to charge divided by current, Q divided by I. So the total charge which is flowing, that is 150 to 10 power 3 divided by the current which is moving, that's 4. But this will give us answer in seconds. Then what we have to do, this answer which is in seconds, as 150 is there divided by 4, it will give 37.5 into 10 power 3 seconds. So we have to convert this, all the options are in hours. What we have to do, we have to divide it by 60 to convert into minutes, and then further divide by 60 to convert into hours. So the correct answer when we solve for question number 30, it will be B. 5.2 hours will be there. Next is question 32. In this question, a thermistor and light dependent resistor LDR are connected in series. A potential difference of 6 volt is applied across as shown. The thermistor has a resistance of 6000 in cold room and 1000 in warm room. The LDR has a resistance of 2000 in dim light and 500 in bright light. When is the potential across LDR equal to 2 volts? So if the total is 6, we want a potential across LDR to be 2. So here we want 4 volts. So what we need greater voltage drop across thermistor. So thermistor resistance should be high and the LDR resistance should be low. And at what condition we have the thermistor resistance be high and the LDR resistance to be low. And the ratio of the voltage and the ratio of the resistance is same in a potential divider circuit. So what is the ratio of the voltage? 4 is to 2, or we can say it is 2 is to 1. So if the ratio of the voltage is 2 is to 1, we want the resistance ratio to be 2 is to 1. So for example, if it is cold and bright, so when it is cold, it is 6000 for thermistor, and when it is bright, it is 500. So when I take a simplest ratio between them, that will come out 12 is to 1. So it means this is not the right answer. If it is cold and dim, so cold is 6000. When it is cold 6000 and dim it's 2000. So 6000 and 2000, when we take a simplest ratio, that will be 3 is to 1. But we want 2 is to 1 as a ratio of the resistance. So this cannot be an answer. If it is warm room and a bright, so if it is a warm room, the temperature, the resistance of thermistor is 1000, and if it is bright, this should be 500 as it is bright. So when you take the ratio, this will come out 2 is to 1. So when the ratio of the resistance is same as the ratio of the voltage, like for a series circuit, that will be the correct option. That's why C is the right answer. Next is paper 2-2 from May-June 2020. The questions in which you have doubt. Question number 4. Determine the angle of the incident at A. So when you draw the normal is always 90 degree or perpendicular to the surface. So if the total angle is 90 and out of this surface and the ray is 30, so this will be 60. So angle of incidence 60. And what about angle of incident at B? When we draw the normal, it is exactly same as the direction of the normal, so angle of incidence for B is 0. Then what happened to ray in B? As the angle of incidence is 0, angle of reflection should also be 0, so it will bounce back or return back to the same direction from where it enters. Next is question 7, C1. State name of the particle emitted as a nucleus R decay to S. If R decay to S, so atomic number is increased or proton number increases. So in which decay proton number increases by, or R to T, the atomic number increases by 1. But here they are asking R to S. So from R to S, this is 83. And whenever there is a beta decay, the general equation for beta decay for element, if it emit out beta, atomic mass does not change and atomic number increases by 1. This is what happens. So if R changes to S, atomic number is increased by 1. So you will mention here a beta decay occur and describe the change in composition when beta decay occur. The neutron number decreases and the proton number increases. And this electron is released as a beta particle. Next is question 8, part C, 1 and 2. At 80, the potential difference across a thermistor is 3.6. What is the definition of potential difference? So definition of a potential difference, it says work done on unit charge when it passes through the component, or work done by unit charge when it passes through a component. Or energy transfer per unit charge. Then calculate the resistance of thermistor when the temperature is 80. So when the temperature is 80 degrees, using a graph you will work out the current. So what is the current in the circuit? So that is equals to, each box is, because this is 0.111, 0.011, 0.012, 13 and 14. So this will be 0.014. That is the current. And what is the voltage? At 80 degrees, they mentioned the voltage that it was having 3.6. So V is equals to IR, or R is equals to V divided by I. So 3.6 divided by 0.014. That will give us the resistance of this thermistor, which is equals to 260 ohms. Next part, electromotive force of a battery is 25. Calculate the resistance R. So if EMF is 25, the total voltage is 25, and out of 25 is 3.6 volts dropped here. So remaining voltage will drop across the fixed resistor. So 25 minus 3.6, it will be 21.4. So 21.4 volts will be dropped across the fixed resistor. And they are in series, so if they are in series, they will have the same current. So 0.014 ampere was moving through thermistor, same current will flow through R. So we have the voltage, which is 2.14, and we have the current 0.014. So we can find its resistance, which will come out 15,000 ohms. Next is question 10. 10 part A3. The charge on one electron is 1.6 into 10 to the power minus 19. Calculate the maximum kinetic energy of one electron. So basically, here the electrical energy transferred into kinetic energy. So electrical energy transformed into kinetic energy. And what is electrical energy? Voltage is work done per unit charge or energy divided by charge, or work done or energy is equals to voltage multiplied by charge. So voltage is given 2000, that's in the beginning, multiplied by the charge of one electron, which is 1.6 into 10 to the power minus 19 coulomb. So you will get this energy, which will come out 3.2 into 10 to the power minus 16 joules. Then 10 part B2, B2. Calculate the time for one oscillation, one complete wavelength and dimension. So time to complete one oscillation, how many boxes are there? 1, 2, 3, 4 boxes are there, and each box stands for the setting of it is 10 millisecond per division, means one box stands for, like starting from here, 1, 2, 3 and 4. So each box dimension, it stands for 10 millisecond. So there are 4 boxes. So what will be the total time? The total time interval will be 40 millisecond, or 40 into 10 to the power minus 3. Then question 10D part 2. A diode is connected to oscilloscope. So what will happen? Because the diode and AC supply is there, so this is what is coming from the microphone. But what is passes through diode when positive and negative, diode will allow that component to pass. But when the terminal changes, the diode will block that current to pass. So one cycle it will allow and another one it does not allow. So what we have to do, we have to draw a trace here to show that a diode which allow one component to pass and another one does not allow, which is also called rectification. So diode actually rectify AC and convert into DC. So this was May-June 2020 paper 2-2. The last one is October 2020 paper 2-2. The first one, question number 1. Eight. Yeah. Calculate the total mass of beaker and the content. How we can calculate the total mass of the beaker and the content? You know, density is mass over volume. So mass is equals to density multiplied by volume. Density is given 1.8. A glass beaker has a mass of 50 gram. We need the total mass of a beaker and the content. So first we'll find the mass of the liquid, because the density of a liquid is 1.8 until it reaches 200. So that is the volume. So density multiplied by volume, 1.8 multiplied by 200, that will give us the mass of the liquid inside. But total mass of a beaker and the content, so beaker is 50 and the content mass, because 1.8 multiplied by 200, that will give 360. So 360 is the mass of a liquid plus the mass of the beaker, so the total mass will be 410 grams. One B2, the meter rule is placed in a pivot that tip of the pivot is under 80 centimeter mark. The beaker with its content, the position as shown. On one side of a beaker at 84 and the other side at 92. Calculate the mass of the rule. So we'll consider it as a uniform. So clockwise moment is equals to anti-clockwise. So one side is 84, another side is 96. 92. So the center will be between them. So what we'll do, how to find center? So it will be 84 plus 92 divided by 2. So this average will be 88. So this is at 88 centimeter mark and this one is at 50 centimeter mark. And the clockwise moment equal to anti-clockwise moment if it is balanced. So this way, this mass we already calculated in the mass of the content that was in the previous 410 into the distance from the pivot. So if it is 88 centimeter mark and pivot is 80, so this will be 8 and this is 30 and unknown is their x. So x into the clockwise moment, anti-clockwise moment are balanced. So x into 30 is equals to 8 into 410. And so x will be equal to 8 multiplied by 410 divided by 30. So this will give us the value of the meter rule mass, which is about 110 grams. Question 4b2. Specify, it shows a metal worker heating a horseshoe at a high temperature before shaping it. And 4b2 is there's a doubt. Calculate the thermal energy transfer a horseshoe by dropping into 8 kilogram of water at 18. Final temperature of water is 43. Specific heat is there, so E is equals to Cm delta T. Specific heat is 4200. The mass of the water is 8 kilogram and the temperature change will be 43 minus 18. So this will give us the energy which is transferred. This will come out as 840,000 joules. Then calculate the temperature of a horse immediately before it dropped into water or horseshoe. So, and the thermal capacity is given. So what is our assumption? That all of this energy which is transferred to the water is from this horseshoe, and we have the formula, the thermal capacity is energy divided by change in temperature. So the temperature change will be equal to energy divided by thermal capacity. So energy, that is 840,000 joules divided by the thermal capacity, which is given 850. So we'll get the temperature. So this will give us the temperature change. The temperature change will come out as 988. But in the question, we don't need temperature change. We need the temperature, the final temperature, the original temperature, the starting. Because when the metal worker then cool the horseshoe and dropping, the final temperature is 43. So basically the temperature change is greater minus smaller. So temperature change, the final temperature, initial temperature will be higher and the final temperature will be lower. That's why for horseshoe it is T1 minus T2. The temperature change is 988. Initial temperature is 43. So final temperature is, we don't sorry, initial temperature we are finding, and the final temperature is 43, that it will come in thermal equilibrium with water. So initial we don't know, and the final is 43. Subtracted, other side it will be added, so 988 plus 43 will give us the final temperature, which will come out 1013 degree centigrade. Next question. Question 5b is also a doubt. State the name of a wire in which fuse is connected. So we always connect fuse in the live wire. So the fuse is always, because we have live and neutral wire for working of the device. Live wire, the charge is vibrating and transfer, having a high energy, so transfer to the component. We always connect a fuse to a live wire. And why fuse connected to this wire? So fuse is to protect the component. If too high current is there, it will melt, the fuse will melt, and it will protect the device. So when fuse melt, it disconnect the device from live wire. So it will protect the device. It will not affect the device, as there is no contact between the live wire and the device. Then 5c, state name of each of these wires. The cable of hair dye contain only two wires. Look, for working of the device, what we need a live wire and we need a neutral wire, because earthing is for safety, to protect the person from getting electric shock, but for device to work, two wires which are needed, live and neutral. Question 6, part B 1 and 2. 6b1 and 2. Phosphorus 32 decay by beta emission to a stable isotope of sulfur. Half-life of this decay is 2 weeks. State how a nucleus of this isotope of sulfur is different from a phosphorus. So if it is emitting out beta decay, what happened in a beta decay? A beta decay, neutron breaks into proton and electron, and that electron is a beta. So this phosphorus, because phosphorus 32 is there, is turned into sulfur. So what will happen? The number of the neutron will be less, and the number of the proton will be higher. Number of neutron decreases by 1 and the number of proton increase by 1 because of beta emission. At time t is equals to 0, radioactive sample contains 3.2 exponent 11 phosphorus. At sample does not contain any sulfur. Plot a graph to show how total number of sulfur atoms. So in the beginning we don't have sulfur. Like in the beginning we have all phosphorus 3.2 into 10 to the power 11. Then after half-life, after 2 weeks, because they mentioned the half-life is 2 weeks, so after 2 weeks it will be half of this original. So we will have 1.6 into 10 to the power 11 sulfur will be there, and 1.6 into 10 to the power 11 phosphorus will be there. So after 2 weeks we'll have 1.6, each box is representing 0.2, so 1.2, 1.4, 1.6. So this will be number of sulfur. And then phosphorus will further decay, half of 1.6, so it will be 0.8 into 10 to the power 11 sulfur will be there, and 0.8 into 10 to the power 11 phosphorus. But what is the total number of the sulfur? 1.6 plus 0.8, so it will be 2.4. So this will be 2.4. And then after further half-life, means after further 2 weeks, it will be 0.4 into 10 to the power 11 phosphorus and sulfur. But what is the total number of the sulfur present? Because we are plotting a graph for sulfur total. So 0.8 plus 0.4, it's basically 2.4. It was there till this point plus 0.4. So it will be 2.8. So when we sketch, this will be the rough sketch. And then after further, it will be 0.2 more. So approximately it will be 3. The graph will be like this. Then question 7b. A bus leaves a bus stop at t is equals to 0, travel along a horizontal road until reaches the second bus stop. The figure 7.1 is a distance time graph. The second B is a doubt, 7b. The maximum speed of a bus during these 160. So what we have to do, we have to draw, because to get a distance time graph, slope represents speed. So we have to find the region where it is having a maximum speed. Here the slope is increasing, and this region it is having a maximum speed. So and take any 2 points and find the gradient, which is y2 minus y1 over x2 minus x1 to get the maximum speed. And the next part, calculate the average speed of a bus between leaving the first bus stop and arriving at the second. So average speed is the total distance over total time. So what is the total distance travel? The total distance, because this is when it starts its journey and it reaches the stop here. So total distance, each box is 10, so this will be 390, and the total time is 40, so the average speed will be 390 divided by 40. Why we do not include this part? Because it ends the journey. This part is the journey finished. We just have to find average speed from one bus stop to another. So from 390 divided by 40, we'll get the average speed. So this was the question from October November 2020 paper 2-2.